Edx M3 June 2010 question 2, and it's on variable acceleration, where the acceleration is a function of x, a function of displacement. Here's the question, and I've just added a diagram. Take a moment to pause the video and read the question carefully. Okay, let's continue then. They tell us the magnitude of the force is inversely proportional to x squared, so I've used that to form this expression for it. Now the minus sign is important. It's because the force acts towards the centre of the Earth. X is measured as the distance from the centre of the Earth. So the force acts so as to decrease x. So strictly speaking, we need to put a minus sign there then. Okay, and the acceleration it causes will be a minus as well. Now, first of all, just for 3 marks, they want us to prove that the magnitude of the gravitational force is that expression. So what that means, if you compare that with mine, is we've got to find k. And this is something they ask fairly frequently. What we know, and they're actually spelling it out for us in the line just here, we know that when x is r, the force on a particle of mass m is mg, because the acceleration is g. So all we've got to do for 3 marks is to say mg, just comparing the magnitudes, we need to put the minus sign in here. Mg is k over r squared. So k equals mg r squared, and that gives us f. The magnitude of f then is mg r squared over x squared as they require. So that's 3 fairly straightforward marks. Now for 7 marks, the next part of the question. As you can see over on the right here, I've translated the words into some initial conditions, well, not initial conditions, some conditions in terms of values of x and corresponding values of v. When the particle was fired from the surface of the Earth, its speed was 3u. That translates into x equals r, and v is 3u, because it's the distance from the centre of the Earth that x represents. At height r above the surface of the Earth, so when the distance from the centre is 2r, v is u. And we're going to use those conditions in a moment. We've got to find u, find the speed in terms of g and r. So let's bring in an expression. Let's bring in the velocity now. So we've got the acceleration, which in all problems like this where the acceleration is in terms of x, we don't write acceleration as dv by dt, but as v dv by dx. And the acceleration is given by minus gr squared over x squared. I've just divided the force by m. So that's the expression for the acceleration. And it's in a form we can integrate now. So we've got the integral of v dv is minus the integral of gr squared over x squared dx. And carrying out that integration, we get v squared over 2 is gr squared over x plus a constant. Now, this is where the conditions that they gave us about what that I've listed at the top here come into it. So let's go to the next page to finish this. Putting those in then, first of all putting x equals r in. X equals r, we've got 9u squared over 2, beg your pardon, it didn't come out properly, 9u squared over 2 equals gr squared over r plus c. So that's 4.5u squared equals gr plus c. At x equals 2r, we get u squared over 2 then. Just check these values. So we get 0.5u squared equals gr over 2 plus c. And what we want then is an expression for u squared in terms of g and r, which you can see what we have to do now. Just subtract those two equations. We get 4u squared is gr over 2. So u squared equals gr over 8. There we are. So that's that question finished. Just look at the mark allocation for a minute. For the first part about finding the magnitude, finding k effectively, and finding the magnitude of the force, then there was an M1 for writing the correct expression for F, and an M1A1 for putting that in and getting that. Okay, and then for the main part of the question, there was a lot of method marks here. There were 2 method marks for, actually let's just see, there was more than that. There were surprisingly many marks for this. There was 2 method marks for writing v dv by dx equals minus gr squared of x squared, and there was an M1A1 for correctly integrating it and getting a plus c. And then, carrying on that, there was, let's see now, there was M1 marks for putting in the x's r and x equals 2r, and A1 marks for getting the expressions. So there's an M1, A1 for each of these. And a final A1 at the end. That's right. I think I've got all the marks there. Okay, so that's the end of that question. I hope it was useful. And there's some information about the Further Maths Support Programme. Thanks for listening.